Welcome to part 3 of section 8.1, where we're going to talk about imaginary roots. It's almost an identical process of what we did in the first video, which was take some of these square roots of both sides to get x by itself. But now, because we're dealing with negative radicals, we have a little bit more steps, and we have to deal with I, which is the square root of negative 1. Let's go ahead and get started. So we have x squared here. We want to get x by itself, so we need to undo the square by taking the square root. Once we do that, we get x equals, now, because it's a square root, we're going to have two answers. We're going to have the square plus square root of negative 18, and we're going to also have the negative square root of negative 18. Now, what we do here is we are going to separate negative 18 into square root of negative 1 times the square root of 18. We can simplify both of these. We know that this is equal to I. That's the whole point. If we have negative square roots, this is equal to I. So we're going to rewrite this guy as I. Now, square root of 18, I like using the factor tree method. I do this extensively in other videos if you want to check it out. But basically, I break it down into its prime factors. I'm going to circle pairs. One of those numbers is going to leave the house. Any number left in by itself is going to stay home. So this becomes 3 radical 2. So I'm going to go ahead and write that there. Times, might as well use the green, 3 radical 2, plus or minus. I just need to rearrange it so it looks a little bit better. I have 3, whoops, forgot my plus or minus 3i, 3 times I is 3i, radical 2. There's my two answers. Moving on to letter B. Here we do the same exact process. We take the square root of both sides and we get x plus 2 on the left. That was the whole point, to undo the squared, equals plus or minus radical negative 16. Okay, let's break down radical 16 first. Plus or minus the square root of negative 1 times the square root of 16. And that is equal to x plus 2. Now, here we know that this is equal to I, so we're going to go ahead and simplify that. And we know this is equal to 4. We already accounted for the plus or minus with the square root, so we're good to go there. So we have plus or minus, and then we have x plus 2 equals that. So let me write it. X plus 2 equals positive 4i. This is where we need to split. If we have, most of the time when we have binomial and we take the square root of it, we're going to have to split here. Okay, so we split this into x plus 2 equals 4i, and then x plus 2 equals negative 4i. We're going to solve for each of these, negative 2, minus 2, minus 2, and we get one answer equals x equals, and technically with complex numbers, you should write the real part first, plus 4i. There's one answer. Let me circle that in orange. It'll stand out a little bit more. Okay, and then we're going to do the same thing over here. We're going to subtract 2i, not 2i, but 2. And we get x equals negative 2 minus 4i. The real part goes first. We have the orange. There we go. So we have two answers just like we did before, but now we have to deal with the I component where we didn't have to deal with that before. Okay, we can still complete the square also. So here we're supposed to complete the square. So we're going to follow our rules, which is we want it into the form where the constant's on one side of the equation by itself, plus 2x. And now I'm going to get my completing the square ready here. Negative 7, and then of course you need this on both sides, plus. Now how do I complete the square? I need to take half of 2. Half of 2 is 1, and I'm going to square it. Well, guess what? That's just 1. That makes it a little bit easier for us. So I add 1 to both sides. Now I'm ready to put it into parentheses squared. That's x plus 1. That's a perfect square trinomial. That's the whole point. Equals negative 7 plus 1, negative 6. Now I'm ready to solve. Take the square root. Take the square root. I get x plus 1 equals the positive square root of negative 6. And it also is going to equal x plus 1 equals the negative square root of negative 6. Let's start over here with let's start with the negative. It's like the bad news first, right? So I subtract 1 from both sides. I get x equals negative 1 minus the square root of negative 6. Don't leave it like square root of negative 6, though. Let's try to take out the I. So we have x equals negative 1. Square root of negative 6 is the same thing as square root of negative 1 times the square root of 6. That's I radical 6. So negative I radical 6. There's our answer. I'm choosing a different color to stand out, of course. Okay, I already know that negative 6 is going to become I radical 6 equals x plus 1. I subtract 1, and I get x equals negative 1 plus I radical 6. And I'm changing color for emphasis. And that is a quick tutorial on how to do roots with imaginary numbers. Hope this was helpful, and I'll see you next time when we talk about 8.2 on Wes Explains Best.